Whereas in 3 marks question, we will get a simple question, that is also finding the area of a given curve. If for all a comma b belongs to the set A, if A star b is equal to C, which also belongs to the set A, then star is called a binary operation. If is sin inverse x plus cos inverse x is equal to 5 by 2, therefore the value of x is also equal to 1 by 5. That's it. Hello dear students, welcome to this session of second PUC Mathematics model paper discussion. Today I am going to discuss the model paper for second PUC Mathematics 2021 and 22. Before going to the exact question paper, let us know regarding the few important things. What are the few important things? Now the question paper pattern. The important is the question paper pattern. You are much familiar with the question paper. Now let me discuss that first. Here in the question paper you will have A, B, C, D, E, 5 parts, that is part A, part B, part C, part D and part E. So there are 5 parts, part A, part B, part C and part D and E. Now in part A, all 1 mark questions. So you will get only 1 mark questions in part A. In that part A, for this academic year, you will have 15 questions. Out of these 15 questions, you are going to answer 10 questions. So 10 out of 15. So the total marks is 10 marks. There are 15 1 mark questions. You are going to answer for 10. So 10 out of 15 questions, 1 marks. Now for 2 marks questions, you will have 18 questions. So the number of questions in 2 marks will be 18 questions you will have. In that you are going to answer 10. Again 10 out of these 18 questions. So in 2 marks you are going to get 18 questions. In that we are going to answer 10 questions. Now similarly in part 3 description type, there are 18 questions. In that you are going to answer for 10 out of 18. So 2 marks questions, 18 questions. Similarly 3 marks question, 18 question. In that in 2 marks you are going to answer 10 out of 18 and in 3 marks you are going to answer 10 out of 18 questions. So whereas in 5 marks there are 12 questions. In this 12 you are going to answer for 6. Is to be answered out of these 12 questions for 5 marks. Now the last part E contains 3 questions. In these questions you are going to answer only 1 question. So in that you will have 1 6 marks question and 1 4 marks question here. So here this is the distribution of the marks in part A, part B, part C, part D and E. So for part A you will get 10 marks and for part B it is 20 marks, for part 3 30, for part 5 that is D it is 5 mark question is 30 and part E this is 10, totally the 100 marks. So here you will have the number of questions. The number of questions are 66 questions. In that you are going to answer, number of questions to be answered is 37. So 66 questions. In that you are going to answer for 37 questions. So many number of choice questions. See, in 1 mark you have 5 choice questions. In 2 marks you have 8 choice questions. Whereas in 3 marks you have 8 choice questions. Again in 5 mark questions you have 6 choice questions. Whereas in 10 marks, that is 6 plus 4, you will have 2 choice questions. So the number of choice questions are definitely you will get good marks. You can concentrate so that you will get 100 out of 100 in this examination if you concentrate according to this. Now let me discuss regarding the blueprint. Now what is the blueprint for this? Now how the questions are distributed? How many questions you are going to get in chapter number 1, chapter 2, chapter 3, like that. Now the first chapter is the relations and functions. So in first chapter, relations and function. So part A, the 1 mark, there are 2 1 mark questions and 1 2 mark question, 1 3 mark question and 2 5 marks question. So here you may expect the problem based on the definitions and simple problems related to relations and functions. Here also simple problems, whereas in 5 marker questions you may expect the question from invertible function. proving the given function as 1, 1 and onto and finding the inverse. Those type of questions you may expect in part D, that is for 5 marks. So totally in first chapter relations and functions, it will fetch us around 17 marks. Very easy to get the 17 marks from this chapter. Now come to the second chapter. This is inverse trigonometric function. In inverse trigonometric function, so you will get 1 mark, 2 1 mark questions and 2 marks question and 1 3 marks questions. So there is no 5 marks, 6 marks and 4 marks questions in inverse trigonometric function. So in inverse trigonometric function, only 1 mark, 2 marks and 3 mark are question. So 2 1 mark questions, 2 2 mark question and 1 1 mark question. So totally the total marks you are going to get in inverse trigonometric function is 9. Now let us come to the very easiest and important chapter, matrices and the determinants. In matrices and determinants, we will have 1 1 question. So usually you will get the problems writing the order or a definition or construction of the matrix. So here for matrices we will have 1 1 mark question and 1 2 mark question and 3 marks question and 1 5 marks question. Matrices particularly we will expect a question based on operations on matrices like addition, subtraction, multiplication, that is scalar multiplication, matrix multiplication and the transpose of the matrix. So you will get 1 5 marks question based on that operations on matrices. Now if you come to the second, the determinant chapter, next chapter, determinant. In determinant also we will have 1 1 mark question, 1 2 marks, 1 3 marks and as usual 1 5 marks question. So here the marks for this is 1 2 mark question, 1 3 mark question and 1 5 mark question. In addition to that, you will have 2 4 marker questions here. So usually the 4 marker question here may be from finding the inverse by Cayley-Hamilton theorem. So finding the inverse whenever the given equation satisfies the given condition. And another problem you will get from the properties of determinant. So you will get 2 questions 4 marks, that is one from properties of determinant, another one from invertible matrices. And whereas for 5 marks definitely you will get a question from matrix method, solution of a system of equation using matrix method. Now and in continuity, let us come to the next important and very important and the maximum marks you are going to get is from continuity and differentiability. So in continuity and differentiability you will have 1 4 mark question in continuity. In continuity you will have 1 4 mark question, that is in part E, for part E. And so you will have 2 1 marker questions and then 3 2 mark questions and 3 marks question and 1 5 mark question. So here the questions may be from different methods of differentiations, that is different types of differentiations like parametric differentiations, implicit differentiations, logarithmic differentiations and exponential differentiation and secondary derivatives. Whereas for 5 marks definitely you will get a question from second derivative. So second derivative questions are familiar with this 5 marker questions. If you study perfectly the second derivatives, you are going to get 1 5 mark question from second derivatives. The total marks for this chapter is 26 marks, that is continuity and differentiability. Now let us come to the application of derivatives. Now in application of derivatives, so we will have 1 question for 2 marks, 1 2 marks question and 1 3 marks question and 1 5 marks question and 1 6 marks question. So that is, you may expect 1 6 marks question from this application of derivatives. So that is from either maybe maxima or minima or from the rate measure. Now similarly if we come to the next concept, the integrals, 1 mark 2 questions and then 2 mark questions 3, and whereas 3 mark questions is also 3 and 5 marks question you will get 1 5 marks question and 1 6 marks question. This 6 marks is from properties of a definite integral. There are 6 properties. From that you will get 1 6 marks question from properties of integrals. Otherwise sometimes you may get 1 question from some important integrals. So here these are the distribution for integrals. Now here also this is also a very important chapter. This will fetch us around 28 marks. Now the next one is the application of integrals. In application of integrals you won't get any 1 mark question or 2 marks question, only a 3 mark question as well as one 5 mark question. So a 3 marks question and a 5 marks question. So here in 5 marks you may expect a question from finding the area of a curve. Either it may be a parabola, hyperbola, ellipse. Whereas in 3 marks question you will get a simple question, that is also finding the area of a given curve. Now these are the distribution of marks for the following chapters. Now the next chapter we are going to study is the differential equation. In differential equation, so there is no 1 mark question, one 2 mark question and one 3 mark question and one 5 marks question. So usually here in 2 marks you will get one question related to order and degree, finding the order and degree of a differential equation. Question very important and very easy to get the 2 marks, and whereas in 3 marks questions you will have 2 questions. One is solving the differential equations either by variable separable method or by linear differential equation method or by homogeneous method, and another question is definitely from the formation of a differential equation. So you may expect one question from formation of a differential equation and another question may be from solution using variable separable method. And if you come to the 5 marks, definitely you will get a question from linear differential equation. So LDE, one 5 marks question from LDE, that is finding the solution, and finding the solution from homogeneous or from variable separable method, and the 2 mark question is from order and degree of the differential equation, and this is also very easy to get 13 marks. Now let us come to the next concept, that is algebra, vector algebra. So in vector algebra you will have only 1 mark, 2 mark and 3 marks. See here, for 1 mark you will have 2 questions, 1 mark 2 questions, and 2 marks 2 questions, and 3 marks 2 questions. So that will carry around 12 marks. So in 1 mark you may expect finding some definitions and finding the values of a unit vectors, finding the unit vector, and whereas in 2 marks question you may expect the problems based on dot product and cross product, like finding the projection or unit vector or finding the area of a triangle, area of a parallelogram, like that. So whereas in 3 marks question you may expect the question from finding the area of a triangle whenever the 3 points are given, and finding the value of a parallelepiped, or finding the box product or a scalar triple product of a vector. From that you may expect one question. So totally it will fluctuate around 12 marks. Now let us come to the next chapter, three-dimensional geometry. So once if you know the vector algebra, then it is easy for you to solve the problems in three-dimensional geometry. In 3D geometry you will expect one question for 1 marks. Usually it may be from finding the direction ratios or direction cosines. Direction cosines, LMN, alpha, beta, gamma are given, finding the direction ratios or direction cosines, and 2 marks questions. So usually you may expect the question from finding the vector and Cartesian equation of a line or a plane. Then one 3 mark question and one 5 marks question. Usually this 5 mark question is from, there are 5-6 derivation, in that you are going to expect one derivation for this 5 marks. So totally this will carry around 13 marks. Now, and the next chapter is the very easiest and the important chapter is the linear programming problem, LPP. In LPP you don't have 2 marks, 3 marks, 4 marks, 5 marks, only 1 mark and 6 marks question. So one mark question is usually from the definitions like what is a objective function, what is the feasible region, what is the feasible solution. So there are few definitions, you are going to get one definition from that part, and one 6 marks question, finding the solution using graphical method. So solving a problem using graphical method you may expect from this. So totally 1 plus 6, 7 marks from this. And the last and the easiest important chapter is probability. In probability we will have one 1 mark question and one 2 marks question, one 3 marks question, and there are 2 5 marker question from this. So you may expect one question from Bayes theorem and Bernoulli's distribution for this 5 marker question. So totally this will carry 16 marks. So linear programming problem 7 marks and probability is 16 marks. So these are the distribution of marks. This is the blueprint for your 2022 April examination. So this is the blueprint. So usually in 1 mark you will have 15 questions, In 2 marks, you will have 18 questions. For 3 marks, also 18 questions. For 5 marks, you will have 12 questions. And 6 marks, 3 questions. And 4 marks, also 3. So, totally the question paper will be set for 195. So, in this 195, you want to answer for 100. 95 marks as the choice question. So, you will have 95 marks as choice, almost equal to 2 times, 1:2. This time it is very easy for you to score 100 out of 100 because this time the choice questions are more compared to the previous years. Hope you followed. Now, let us come to the question. Now, today I'll discuss one model question paper. Okay. Now, the subject mathematics, you will have 3 hours 15 minutes to read the question paper, and the maximum marks is 100. And the question paper, in this question paper you will have 5 parts, that is, as I told, question paper contains part A, part B, part C, part D and part E. Answer all the parts. These are the instruction typed in the question paper. So, I am taking a question paper. It's a model question paper. The question paper has 5 parts, namely A, B, C, D, and you answer all the parts. So, you have to answer all the parts. Now, use the graph sheets for the questions on linear programming part E. So, for part E, wherever it is required, use the graph sheet. Now, let us come to the first part, part A. In part A, you will have 10 questions. So, answer any 10 questions. How many questions are given? See, as I told in the previous, just now, while explaining the blueprint, the question paper will be according to the blueprint only. So, here the questions are based on relations and functions, inverse trigonometric functions, and then matrices, then determinants, differentiations, then again integrations, application of integrations, and vector algebra, 3D, and then linear programming, and then the probability. Okay, so these are the problems for part A. So, see here, this part A contains 15 questions. In this, we are going to answer for any 10. Answer any 10 question from this. So, next, in part B. In part B, so yes, these are the questions for part A. So, 6, 7, 8, 9, I will explain one by one. Then, these 15 questions are there in part A. Okay. Now, next in part B, as usual, in part B, we will have 10 questions to be answered. Answer any 10 out of 18 questions. Here you want to answer 10 questions out of this 18 questions. So, this is also same as that of the blueprint. So, the first question is from relations and function, and second from inverse trigonometric function. Second question is also from inverse trigonometric function, and the third question is from matrices and determinants. Okay. Now, let us come to the next question. The question number 20 is from differentiation. Again, 22 is also from differentiation. 23 is also differentiation. That means there are 3 questions from derivatives, 2 marks questions. And again, next the question is from application of derivatives. Then we are going to study regarding this problems based on integration. So, 2 questions from integrations for 2 markers, and again 1 question is from application of integration. So, I will explain all these questions. I will solve all the questions while solving the problems. I will go to first part A, part B, part C, part D and part E. Now, let me see the questions, how the questions are asked. Now, find the order and degree of the differential equation. This is from differential equation. Then from vector concept, finding the area and the projection. Again, so 3D geometry, finding the intercept of the plane. 2x plus y minus z is equal to 3 is the given equation. And again it is from the 3D geometry, that is the distance of the point from the plane. Then the question is from probability, and so the last question 33, question number 33 is from probability. So, these are the questions for 2 marks. Now, in the part C for 3 markers, what are the questions we will have? See, these are the questions for 2 marks, right? Now, let us come to the part C. In part C, we will have part C, same. You have to answer 10 out of 18 questions. So, each question carries 3 marks. So, as usual, here in the first question, we will have the relations and function, and second one is inverse trigonometric function, third one is matrices and determinants, And the fourth question is for third is matrices, fourth one is determinants, 37th question for 3 marks. Then differentiations, types of differentiations, logarithmic differentiations, parametric and mean value theorems, right? Then integrations, then definite integrals as limit of a sum, then finding the area, that is application of integration. So these are all comes under 3 marks question. Now let us go to the next question. So the next question is from differential equations, formation of a differential equation, and then again from differential equation finding the solution. As I told now itself, the differential equations you may get one question for formation, another question for the solution. Now one question from differential equation for differential equation, one question is for formation, another question this is for finding the solution using variable separable method or homogeneous or LDE. Now here one question from vector algebra for 3 marks, and the remaining questions are from 3D geometry. So these are, you can use this for you can solve using vector method or 3D method, and the last question is from probabilities. These are the questions for a 3 marker. Now let us come to next very important part, that is part D. So this will contains 30 marks. So here you are going to answer only 6 questions. Answer any 6. How many questions you want to answer is 6 questions out of 12. So here there are 12 questions. Out of these 12 you are going to answer 6. Each carries 5 marks. So the first 2 questions usually 52 and 53 from relations and function, that is finding the invertible function, just by verifying whether f is 1 1 and 2 and finding the invert. So inverse. So the same concept questions you are going to get for 52 and 53, 5 marks question from relations and functions. And the next 54 is from matrix multiplication, that is operations on matrices, as I told, addition, subtraction, scalar multiplication and the transpose of the matrix. Now the next question is from determinants, that is solving a simultaneous equation using matrix method. Then the next question is from second derivatives. As I told, there are few questions in second derivatives. If you practice those questions, definitely will get one question for the point of examination. And the next question is from the application of derivatives. Here you may get the question from rate measure or from maxima or minima. Now then the next question is integrals. So you may expect one question for 58 question from some important integral. There are 6-7 important integrals. From that you are going to expect one question for that. Now and next, application of integrations. The 59th question is from application of integrals, that is finding the area of any given curve. Usually we may expect a question like finding the area of a circle or a ellipse. Now the next question is from differential equation. Usually the question here may be from a linear differential equation. Now then the next question is from 3D geometry, equation of a line or equation of a plane. So the last 2 questions, 62nd and 63rd question, are from probability. So you will expect a question from Bayes theorem or Bernoulli's distribution. Now after this, let us come to the next very easiest and the important part, that is part E. In part E, you will have 3 questions. In that you are going to answer only one question out of 3 for 10 marks. So here you will have 3 questions. Each questions contain 2 sub questions. See 64, it contains A and B. So you have to answer both A and B. If you go to 64, answer A and answer B. Answer A and B are compulsory. So 6 marks question is from linear programming problem, finding the solution, solving an equation using graphical method, that is from LPP, and related to that you will get 1 4-mark question either from matrices or from continuity. So here the equation is given, we have to find the inverse, otherwise you may expect this question also there, right? Now in the second question you will have a problem based on the properties. There are 6 important properties. From that you will get one property for derivation and the problem related to a particular property. So that is from 65A. And for B you may expect a question from continuity, or either it may be from properties of a determinant. The next question, the last question, may be from the question number 66. 6 marks question is from, that is from the application of derivatives, just finding the volume of a sphere or a cone, whatever it may be. One is from application of derivative, and the next B is from the properties of a determinant. These are three types of questions which you may expect for 10 markers. Definitely you will expect one linear programming problem, one problem based on properties of definite integrals, and one problem based on maxima or minima or application of derivatives, right? Corresponding to that, you may expect 4 mark question from determinants, properties of determinants, continuity, and the problems based on finding the inverse using invertible, that is using the Cayley-Hamilton theorem. This is the question paper that now I am going to discuss. Now this is the question paper. Now today I am going to discuss regarding this question paper. Let me discuss with the first part A. Let me start with part A, part B, part C, and part A. Let me start with 1 marker question. I'll start today I am going to solve 1 marker questions. Then after that I will go to the 2 marker, then 3 mark questions, then 5 marks, then part E, that is 6 marks as well as 4 marks. Okay, this is how the question paper pattern. This is the model question paper for your 2022 board examination. Now let me discuss the solution for part A. Now let us solve the problems in part A. 1 marker question. Now come to the part A. In part A, the first question is from relations and function. Give an example of a relation which is symmetric and transitive but not reflexive. See, what is the question given here? Relation which is not reflexive but which is symmetric and transitive. Give an example for a relation which is symmetric and transitive but not reflexive. Reflexive means A comma A belongs to R. If A comma A belongs to R, then it is reflexive. Now, you have to give an example for this relation so that A comma A does not belongs to R. Now, let us consider, let us define a relation R on a set. Let R is a relation on a set A is equal to 1, 2, 3 as R by, let us define a relation R on a set A is equal to 1, 2, 3. The elements of the set are 1, 2, 3 by R is equal to, the relation R is equal to 1, 1, 2, 2, 1, 2 and 2, 1. This is the relation. Let us define a relation R on a set A is equal to 1, 2, 3 by R is equal to 1, 1, 2, 2, 1, 2 and 2, 1. So clearly here, this is not reflexive, This is not reflexive because 3, 3 does not belongs to R. 1, 1 is there, 2, 2 is there, but 3, 3 does not belongs to R. Now verify whether it is symmetric. What is symmetric? For the symmetric property is, what is symmetric? A comma B belongs to R implies B comma A also belongs to R. That is 1, 2 belongs to R implies 2, 1 also belongs to R. Therefore, this is a symmetric. You can also verify transitive property. What is transitive property? Transitive. That is A comma B belongs to R and B comma C belongs to R implies A comma C also belongs to R for all A comma B comma C belongs to the set A. See, you can verify that. So just here, if you give, this is sufficient for you. That is, let R is a relation on a set A is equal to 1, 2, 3 defined by R is equal to 1, 1, 2, 2, 1, 2 and 2, 1 is an example for a relation which is symmetric and transitive but not reflexive. That's it. 1 mark. If you do this much, you will get 1 mark. Okay. Let us come to the next question. Question number 2. So define a binary operation. So a binary operation. It's a rule in which any two elements of the set will combine to get one more element which is also included in the set. Then that operation star is called a binary operation. Now how to define? So a binary operation star on a set is a function. A binary operation star on a set A is a function star such that A to A cross A to a function star such that A cross A to A is denoted as A comma B by A star B is equal to A star B for all AB belongs to A. That is A comma B belongs to A, then star is called a binary operation. That is, you can also define like this. If for all A comma B belongs to a set A, if A star B is equal to C belongs to A, then star is called a binary operation. If you write this much, you will get 1 mark. So, a binary operation on a set A is a function star such that A cross A to A is denoted as function star A comma B by A star B for all AB belongs to A. That is, if A star B belongs to A, then star is called the binary operation. Or you can also write, if for all A comma B belongs to the set A, if A star B is equal to C, which also belongs to the set A, then star is called a binary operation. Now, what is the next question? Question number 3. Find the principal value of cos inverse of minus 1 by 2. Now, you might have been studied if cos inverse x is positive, means the x value is also positive. For cos inverse of minus x, we are going to write it as pi minus cos inverse of x. Now, what is the value of cos inverse 1 by 2? First, you know the value of cos inverse 1 by 2. Cos inverse 1 by 2 is equal to, this is equal to, what is the answer we are going to get for this? Pi by 3, because cos pi by 3 is equal to 1 by 2, right? That is cos of 60 degrees, sin 60 root 3 by 2, cos 60 is equal to 1 by 2. Now, what is the question here given? Cos inverse of minus 1 by 2 can also be written as pi minus cos inverse 1 by 2. This is pi minus pi by 3. Take LCM, 3 is LCM, 3 pi minus pi, that's equal to 2 pi by 3. So, the principal value of cos inverse of minus 1 by 2 is 2 pi by 3. So, whenever cos is negative, we are going to subtract pi minus that particular angle. That is nothing but 3 pi minus pi is equal to 2 pi by 3. This is the procedure, right? So, if it is cos inverse 1 by 2, straight away you can write the principal value as pi by 3. If it is negative, pi minus pi by 3, that's it, okay? Now, let us come to the next problem. What is the question number 4? So, again, this is also from inverse trigonometric function. If sin of sin inverse 1 by 5 plus cos inverse of x is equal to 1, then find the value of x. This is also very important and very simple problem. So, you are familiar with these relations. We know that sin inverse of x plus cos inverse of x is equal to pi by 2. Sin inverse x plus cos inverse x is always equal to pi by 2. Now, what is the given equation? The given equation is sin of sin inverse 1 by 5 plus cos inverse of x is equal to 1. Just transfer sin to the right hand side, then this can be written as sin inverse 1 by 5 plus cos inverse of x is equal to sin inverse of 1. Since what is sin inverse of 1? You know this is sin inverse 1 by 5 plus cos inverse of x is equal to pi by 2. Because what is sin 90? Sin 0, 0, sin 90 is 1, sin pi by 2 is 1. Now, if we compare, this is of the form sin inverse of x plus cos inverse of x is equal to pi by 2. Therefore, the value of x is equal to 1 by 5. That's it. Simple problem. Just see here, transfer sin, take inverse for this. Sin of sin inverse 1 by 5 plus cos inverse of x is equal to 1 can also be written as sin inverse 1 by 5 plus cos inverse of x is equal to sin inverse 1. What is sin inverse 1? Pi by 2, because sin 90 is 1. So, if you observe carefully, this is of the form Sin inverse x plus cos inverse x is equal to pi by 2. So therefore x is equal to 1 by pi. Now let us come to question number 5. Define a row matrix. As you know, a row matrix, column matrix, a matrix having only one row. A matrix having only one row is called a row matrix. Suppose if it is column, a matrix having only one column is called a column matrix. So a row matrix is denoted as A is equal to 3, 2, 1. Or if you want one more, a matrix 3, 4, 5. So these are all row matrices. Contains one row, 3 column, one row, 3 column. Now let me take one more example. Another example, B is equal to 3, 4. This is also a row matrix of order 1 row and 2 column. So a matrix having only one row is called a row matrix. If it is column means a matrix having only one column. Okay. Now let us come to the next problem. The question number 6 is from determinants. Find the value of x if x to 18x is equal to determinant 6 to 18 6. This is determinant. By equality of determinants, you can solve this. Now simplify, expand the 2 rows, 2 column determinant. X into x is x square minus 18 into 2 is 36. Again 6 6 are 36 minus 18 into 2 is 36. So this is x square minus 36 is equal to 36 minus 36 is 0. X square is equal to 36. X is equal to root of 36 is plus or minus 6. So therefore the value of x is equal to plus or minus 6. That's it. Okay. Just very simple and very important type problem. Just simplify, you will get the answer. Now let us come to the next problem. Question number 7. That is from derivatives. If y is equal to e to the power of cos x, find dy by dx. Now what is given? Y is equal to e to the power of cos x. Now differentiating with respect to x. E to the power of cos x. Now differentiating with respect to x, this is dy by dx is equal to d by dx of e to the power of cos x. So function of a function. So chain rule here. So see here d by dx of, you know this, f of x to the power of n is n into f of x to the power of n minus 1 into d by dx of f of x. Okay, now just ordinary differentiate it. Differentiation of e to the power of x is e to the power of x e raised to cos x into d by dx of the power cos x. Okay, function of a function f of x to the power of n. So differentiation, this, let us consider this as e to the power of x. Since you know what is d by dx of e power x is e power x itself. So consider this as x, e power x. Differentiation of e power x is e power x means e to the power of cos x. So d by dx of e to the power of cos x is e power cos x into d by dx of cos x. So you can write dy by dx is equal to e to the power of cos x into differentiation of cos x is minus sin x. So the answer is minus e to the power of cos x into sin x. Within a step you can write. So no need to do all these steps. So if you are familiar, you can write dy by dx is equal to y1 or y dash e to the power of cos x is e power cos x into differentiation of cos x is minus sin x. That's it. Okay. This is how we are going to solve. Now let us come to the question number 8. This is also from differentiation itself. Function of a function. What is given? Y is equal to sine of x square plus 5. What is required to find is dy by dx. Differentiating with respect to x. So dy by dx is equal to d by dx of sine of x square plus 5. Now again this is chain rule. Let us call it as x. What is differentiation of sine x is cos x. Instead of x it is x square plus 5 into d by dx of inside function, that is x square plus 5. So this is equal to cos of x square plus 5 into differentiation of x square is 2x and 5 derivative is 0. So that's it. So d by dx of sine of x square plus 5, call it as x. Differentiation of sine x is cos x, a function of function. Again cos of x square plus 5 into d by dx of inside function x square plus 5, differentiation of x square is 2x. So the required answer is y dash is equal to cos of x square plus 5 into 2x. Okay. Now let us come to the question 9. Now this is from integrals. So evaluate or find the integral So what is the given equation? Given equation is integral 2x square plus e to the power of x into dx. Now you know the standard value, standard integral of x raised to n dx is equal to x to the power of n plus 1 divided by n plus 1 plus c, provided n is not equal to minus 1. Now term by term integration, 2 into integral of x square dx plus integration of e to the power of x dx. So this is 2 into, what is n here? N is equal to 2. Integral of x to the power of 2 is 2 plus 1 is 3 by 3 plus integral of e power x is e power x plus c. 3 and 3 gets cancelled. This is equal to x cube plus e to the power of x plus. So integration of x 2x square plus e power x dx is x cube plus e to the power of x plus c. That's it. Okay. Very simple. You may expect this type of questions for 1 mark, definitely. Now let us come to the next question. Next question is maybe from application of integrals. Right. Now evaluate integral of 1 over x dx between the limits 2 to 3. Now, you know what is d by dx of log x. So, d by dx of log x is 1 over x. You know, the reverse process of differentiation is nothing but integral. So, if you integrate 1 over x dx, you will get it as log x. So, integration of 1 over x dx is log x. Now, the given equation is, what is the given equation? Integral 2 to 3, 1 over x dx. So, integration of 1 over x is log x between the limits 2 to 3. Now, apply the limits. First, apply the upper limit minus lower limit. So, this can be written as log 3 minus log 2. So, you know this formula, logarithm of m by n is equal to log m minus log n. So, this can also be written as logarithm of 3 by 2. So, if you want, you can stop there itself, or you can write logarithm of 3 by 2. See here, integration of 1 over x is log x. Differentiation of log x is 1 over x. Integration of 1 over x is log x. So, integration of 1 over x is log x between the limits 2 to 3. Upper limit log 3 minus lower limit log 2. Log m minus log n is log m by n. You can write this as logarithm of 3 by 2. Okay. Now, let us come to the next question. Question number 11. What is question number 11? It is from vectors. Find the unit vector in the direction of vector A. So, the unit vector in the direction of vector A. What is given? Vector A is equal to 2i cap plus 3j cap plus k cap. Now, you know the formula for unit vector along any vector. Unit vector A cap along vector A is equal to vector by its own length. That's it. Any vector, unit vector along A is nothing but vector by its own length will give the unit vector. Now find out the magnitude of A. Magnitude of A is magnitude of 2i plus 3j plus k. This is nothing but square root of 2 square is 4, 3 square is 9, 1 square is 1. This is 9 plus 1, 10 plus 4 is 14. So you can write it as vector A is 2i cap plus 3j cap plus k cap divided by root 14. This is the unit vector. Or if you want, you can stop here itself. Or if you want, you can also write like this. That is 2 by root 14 into I plus 3 by root 14 into j plus 1 over root 14 into k cap. This is the unit vector. That's it. Okay. Write two different vectors having the same magnitude. Magnitude means length. So, you have to write two different vectors having the same magnitude. So, let us write the vectors as, let vector A is equal to I plus j plus k. Now, what is the magnitude of A? A is equal to root of 1 plus 1 plus 1 is equal to root 3. Magnitude of A is equal to 3. And another vector, vector B is equal to I minus j minus k. I minus j minus k. What is the magnitude of this? Magnitude of this is square root of 1 square is 1, minus 1 square is 1, again 1 square is 1. This is also equal to. So, A magnitude is equal to magnitude B. So, therefore, the two vectors are vector A is equal to I plus j plus k and another vector B is equal to I minus j minus k. These are two different vectors having the same magnitude. You can take any example for this. Let us come to the next problem. This is very important problem. Question number 13. Find the direction cosines of x-axis. This is from 3D geometry. So the direction cosines of x-axis. A line will make, so the direction, to find the direction cosines of x-axis. Suppose if a line cuts the x-axis at an angle, the line cuts the x-axis at an angle of 0 degrees, 90 degrees and 90 degrees. Alpha is equal to 0, beta is equal to 90, gamma is equal to 90 degrees. Then the direction cosines are cos alpha, cos beta and cos gamma, cos 0, cos 90 and cos 90. Thus we are going to get the direction cosines as 1, 0, 0. Because cos 0, sin 0, 0, cos 0 is 1, cos 90 0, cos 90 0. Therefore, the direction cosines of x-axis are 1, 0, 0. If we write this much, the direction cosines of x-axis is equal to 1, 0, 0. That's all. If you write this much, you will get 1 mark. Because it will make an angle of alpha. Alpha is equal to 0, beta is equal to 90 and gamma is also equal to 90. Then the cosine of alpha, cos 0. So sin 0, 0, cos 0 is 1, cos 90 is equal to 0. Again cos 90 is also equal to 0. This is L, M and N. So the direction cosines of x-axis are 1, 0, 0. Similarly, suppose if they ask the direction cosines of y-axis, y-axis is 0, 1, 0. For z-axis, the direction cosines are 0, 0, 1. That's it. So definitely you will get one question from this. The direction cosines of x-axis is 1, 0, 0. The direction cosines of y-axis is 0, 1, 0. And z-axis is, for z-axis, the direction cosines are 0, 0, 1. Okay. Hope you followed. Now let us come to the next question number 14. What is the question 14? So define the feasible region of a linear programming problem. It's from LPP. So you will get one definition like this from LPP for 1 mark. The feasible region. Feasible region means the common region. The common region determined by all the constraints, including non-negative restrictions, non-negative constraints. X is greater than or equal to 0 and y is greater than or equal to 0 of a linear programming problem is called a feasible region. Feasible region means the common region determined by all the constraints. The common region determined by all the constraints, including the non-negative restrictions. So this is the feasible region. So that is the common region determined by all the constraints, including the non-negative constraints x, y greater than or equal to 0 of a linear programming problem is called the feasible region. That means the common region determined by all the constraints, including the non-negative restrictions. This is the feasible region. Okay. This is the feasible region. Now, let us come to the last question in 1 mark. Yes, the question is from probability, right? The last chapter is probability. The last question for 1 mark may be from probability. Now, find the probability of A by B means already B is occurred. Probability of A if B is already occurred. If probability of B is 0.5 and the probability of A and B, A intersection B is 0.32. Now what is given here? Given probability of B is given, probability of 0.5 and probability of A intersection B means A and B is given, that is 0.32. Now what is required to find is the probability of A by B. Probability of A already B is occurred. Now what is given? Probability of B is 0.5. Probability of A intersection B and B is 0.32 and probability of A by B. Now we know the formula, the probability of A divided by B is given by probability of A intersection B divided by the probability of B. So what is the formula? Probability of A by B is equal to probability of A intersection B. A and B divided by probability of B. Now substitute the values. What is A intersection B? That is 0.32. 0.32 divided by what is the probability of B? 0.5. Simplify this. 0.32 divided by 0.5. This will give the required answer. 0.32 divided by 0.5 is nothing but this is equal to 0.64. 5 6 are 30, 5 4s are 20. So 0.64. Therefore, the probability of A by B is equal to 0.64. Probability is always less than or equal to 1. So 0.64 is the required answer. These are the questions for 1 markers. So far, I have discussed the problems for 1 mark from all the chapters. So this is very, very important for the point of examination. So you are requested to answer only 10 out of 15 questions. Now this time getting 100 out of 100 is very easy since there are 5 choice for 1 markers. Definitely if you concentrate more towards 1 markers, definitely you will get centum in mathematics. So these are the problems for 1 markers. So that's regarding today's session. Now let us discuss with the 2 marker questions in the next session. I am going to take 2 marks questions and 3 mark questions. Don't miss. Thank you very much.